Good afternoon. My name is Eliza Tica. I am from University Politehnica of Bucharest. Today, I will present the change point detection in recent hydropower generation in Romania. To determine the moments in which this change occurred, the statistical analysis of the recorded data set is used. For each country, the trend for generation and consumption of electricity is an interesting subject. In Romania, about a third of the total energy generation is from hydropower plants, and therefore it is important to follow the evolution over time and trend of this variable. The aim of this paper is to determine the evolution of hydropower generation as time series from a statistical approach using annual values of recorded data of energy generation from Romanian hydropower plants between 1980 and 2019. These data were published in annual report of Hidroelectrica and Transelectrica websites regarding the national power grid. For this case study was applied the Petit method to determine the change point of this time series. The recorded data used for the hydropower generation for the analysis period are presented on this slide. It can be observed between 1980 and 1990 a continuous increase of hydropower production. The development over time of annual hydropower generation for the period 1990 and 2019 decreased when the development of new hydropower plants was slowed down. From this figure, also it can be noted that for 2 years, 2005 and 2010, the hydropower generation is very high. It is noted that the extreme values observed on the graph are not change points for the time series, and the average of all 40 values is about 14.8 gigawatt hour. This evolution easily indicates a continuous increase for hydropower production over this period. The Petit method is commonly used to detect one change point in the mean value of observed series, especially in hydrology. For the homogeneous subset with different distribution function are defined as static and non-static parameters, defined using the presented equation. It can be considered that where the static of the method has a peak, there is a moment when in the time series occurs a change. The Petit method can be used if one change point is present, for example, one abrupt change of the mean. To find if another change point exists, the original time series can be split into two subseries and repeat the analysis for each subseries. This is based on studying the sign of the difference between two consecutive values. In order to find another change point for 1994 and 2019 period, the Petit method was applied again for the year 2004 that was found as a second change point. The original time series was being split into two subseries, and it was repeated the analysis for the recent period 1994 and 2019 to find the second change point. After applying Petit method for series between 1980 and 2019, the maximum of temporal distributions of the static is obtained for the year 1994. The change in trend is obvious at that time and is since new hydropower plants were commissioned in Romania between 1980 and 1994, and it was slowed down afterwards. For analysis, the time series will be split into three subsets presented on the bottom of this slide. In first table are presented two values of static parameter for first and second change points. In the second table are centralized the main statistical characteristic of the three subsets that have different values for mean and standard deviation. It is observed that for the last period, the average hydro energy produced in the highest and the highest value is obtained in 2010. For each of the three subsets, a linear regression is found which best approximates the discrete values recorded. The recorded data are well approximated by presented regression equation. On this figure is presented the linear regression of hydropower generation in 1980 and 1994. The increasing trend is obviously due to the new hydropower plants that have been constructed in Romania between this period. The slope of the regression line is strongly downward as shown by the regression equation found for the variation of hydropower generation over the presented period. For this period shown in this figure, a decrease in the energy produced in hydropower plants can be observed. From a figure presented on this slide, it can be observed that the trend of hydropower generation in the time period 2004 and 2019 is decreasing, but the slope of the regression equation is low, meaning the downward trend is smaller than for the period 1994 and 2004. The increase is most likely due to the upgrading of hydropower plants during this period. The tendency is to decrease, but the slope is not so abrupt like in 1995 and 2004 period. In conclusion, the original time series was split into sub-series, which allow it to find 2 points change in the series composed of hydropower generation for the analysis period. Using all the values, it was obtained that the year 1994 represents the year when the change point is abrupt and evident due to the construction of the new hydropower plants in Romania between 1980 and 1994, because the important hydropower plants were put into operation, and this including the Iron Gates hydropower plant, Retezat, etc. If only the range of values from the year 1995 to 2019 are analyzed. In the year 2004, the maximum of statistic indicate a change point. The analysis can conclude that for the period 2004 and 2019 exists an increase in average in hydropower generation compared to the year 1995 and also 2004. Thank you for your attention.